Okay.
Excellent. So welcome and thank you for joining us for another episode of the Jane Irrigation Training Series. I'm Richard Restuccia, Vice President of Water Management Solutions at Jane Irrigation. And today we're going to be talking about a hotly debated subject around irrigation people, that is. And that is, what's more important, irrigation scheduling or distribution uniformity? And fortunately, we have two of my favorite irrigators joining us today to talk about this subject. And I do feel very fortunate because I've known both Inge and Tom for a long time, and I've actually had the pleasure of working with both of them for a while. So, our first guest is Inge Bisconer. She's a managing member of Surf and Earth Enterprises. She's also the vice president of the Irrigation Association, which we talk a lot about on these webinars. So we're really happy to have her for that. And, Inge and I worked together. It was more than 20 years ago now, Inge, even though it just seems like a few days ago. And I will say this about Inge, on our team, she quickly became the go-to person for technology and technological questions. I noticed this right away because her expertise in that area was very, very high, higher than anybody else on the team. And we would go to her all the time for that. And the other thing I want to say is, even 20 years ago, you were concerned about water conservation and drip irrigation. And really at that time, you were way ahead of your time. And I always appreciated that about you during that time.
Well, thank you, Richard. It was a pleasure working with you back in the day. Yeah, so I was thinking about that the other day too, over 20 years ago that we were working together. And, it's scary. I've been thinking about how long I have been in this field. It's nearly 40 years. I mean, I grew up in agriculture, on the farm in Tulare, so it's really been a lifetime endeavor in some ways, but professionally, 40 years. So it's a lifelong endeavor for us to help farmers become better irrigators. And that's what we're all doing now. And it's really heartening, and that's the right thing to do.
Yeah, consistent improvement, right? It's going to be that way forever.
A little bit at a time. It's not going to happen overnight, but little by little, and maybe going forward a little more quickly, I think, is what we're going to have to do here in the future.
Yeah, definitely. And then our other guest today is Tom Devol, who's the Senior Manager of Field Outreach and Education for the Almond Board of California. I had the pleasure of working with Tom for several years at Jane. And one thing I really understood about Tom is he really cared about his customers. He wanted to be sure that his customers were getting solid advice, and he was there because Tom's got a lot of knowledge of irrigation and technology, and he was there as a resource for them to make them better growers. And boy, I really appreciated that about Tom. I'm really excited to have him here today to be talking about irrigation scheduling and distribution uniformity. But before we get started on that, Tom, I've got one quick big question for you. And that is, what is the water outlook for the season coming up?
Yeah, it is a big question. And actually, it's been the subject of numerous conversations recently with a few meteorologists. And the hard reality is that we could be going into another dry year. It's hard to think about coming off all this weather, and that weather did help us, but we definitely need some rain, and we could be faced with another dry year. And so the timing of this conversation is perfect because we need to continue to improve. In ag, we definitely have a target on us because we use water to grow our crops, and we're going to have a lot of people watching what we do this year. And this subject we're talking about today is important every year, but this year, if any, this is going to be great content, I think.
Yeah, I think so too. And you're gonna show us a slide rule you've been using, right, to make scheduling easier, right?
Yes. It's a new tool we have this year, and I'm excited to get it out just to illustrate where these costs are to you as a grower, what the impact is, and I think sometimes when you look at hard numbers, it wakes you up a little bit. So.
Well, great. I'm looking forward to that. But first, we're gonna start with Inge, and she's got a few things that she wants to say as well.
Yeah. Thank you and welcome. And it's an absolute pleasure to be part of this webinar. Richard, thank you for the invitation, and thank you, Tom, for partnering with me on this. It's been an absolute pleasure working with the Almond Board over the last couple of years in my new consulting role. since I retired from industry a few years back. Yeah, and that slide rule calculator is one thing that we work together on, and we're really excited to present that today. And yeah, Tom will take the lion's share of that. But yeah, this question of whether, hey, is it more important to, irrigate the right number of hours or days a week, or is it more important that your system itself, that you're scheduling the irrigation for, is uniform and operating properly and in good form? And as we saw in the run up to this webinar, we really say they're both important, and they are absolutely both important. And hopefully everybody understands why at the end of this 30 or 45 minutes. So I'm going to dive into just talking about irrigation scheduling a bit, and then Tom's going to be talking more about distribution uniformity. But yeah, the question, it's basically if you schedule your system perfectly and the system isn't operating properly, you've lost value in the time you took to schedule properly, and vice versa. If the uniformity is perfect, but you're not operating the right number of hours a week or a day, then you're also not getting the value out of your resources. So let's dive into supporting those statements and start with irrigation scheduling. And I'm going to keep this super simple. Richard, you're right. I kind of have the reputation as a techie and can get very technical if you want. But I wanted to keep this very, very simple, because I think somehow, we in industry sometimes get too deep into it and we lose focus, and we don't really get the message across to the growers that need to, understand this and grasp it and enable themselves to do a better job. So at a very, very basic level, I mean, what is irrigation scheduling? Well, it is, when are we going to turn the system on? And I got a little picture of a calendar here. Can everybody see that?
Yeah.
Yes.
A little clip art calendar. What days of the week or the month are we going to be turning our system on? And then the second question is, how long are we going to run it? Now, if you're growing almonds in Bakersfield, like I was back in the early 80s, and those systems were designed at peak in the middle of the summer to operate every day of the week, 24 hours a day, your scheduling is pretty easy. In the peak of summer, when it's really hot and your ETs are really high, up 0.3, 0.4 inches per day, you're running that system 24/7. But that's kind of an outlier. Most of the time, most farmers have the luxury and the opportunity to dictate how many hours and how many days a week to irrigate, to do it properly and not overuse the resource. So those are the two questions we have to answer to schedule properly. So the next slide is, and Richard, you were asking me early, why do people care? Why do you really care about irrigation scheduling? Well, it's important because it's directly related to crop yield and quality, which means money, which means, money in the farmer's back pocket, it's revenue. If you don't irrigate right, you're probably leaving money on the table as far as yield and the quality of your crop.
Inge, if I could just interrupt a second, I wanted to talk about that, when to turn it on and how long to run it.
Yeah, you bet.
Previous slide a second.
Yeah.
Is this an art or is this science? I mean, do we know for sure the answer to this, or is it just people guessing and getting it right or wrong?
No, it really is an art, Richard, because there's a ton of science behind it. But as you see in a future slide, there's so many other things that influence it other than the academic, in theory, how much water does the crop need? We pretty much know how much water the system puts on. That is, that's engineering. We can calculate what the flow rate is of the devices, at what the pressure is. What we don't have a good handle on sometimes is the maintenance level of the system. So what is the distribution uniformity of it? But, that's kind of science, but it's like asking you, do you know exactly how many calories and how many grams of protein and everything that you need as a human being every day to have optimum performance? It's the same thing with a crop. It's a living thing, and it's subject to, weather and season and level of maturity and a ton of other things, what the farmer wants to get out of the crop. So that's a little fuzzy as far as what is the exact right amount of water and nutrients to put on the crop on a daily or weekly or monthly basis. But you can certainly approximate and get pretty close with the science, and then it's an art to juggle it with all your other cultural practices.
Yeah,
So,
and
so the answer is it's a little bit of both.
I think today, compared to 20, 30 years ago, though, we have so many more resources available to us to help us answer that question.
Sure.
We're very fortunate now. There's so many tools now to help.
Yeah.
I
mean,
great
you can
point.
automate this, but at a basic level, even if it's automated, you pretty much are answering the same question. How long am I going to run and when? So that's basic irrigation scheduling, whether you do it automatically or manually.
Right. And like you said, we do know, right, in general, how much water a plant needs. We also know in general how long we have to run an irrigation system to get the water to the root zone.
Yes.
And those two things never change, but there are some other fuzzy things that do change. And I like the fact that you said, what the grower wants to ultimately get from his crop does matter.
Absolutely. Sometimes you do want to stress the crop, to get the result that you want. But it actually, the crop water use does change as the season progresses because of weather and because of crop maturity. So it is a complicated question, and there's a lot of science and technology that goes into it. That's why it's not simple. But there are a ton of resources, as Tom said, and we hope to share some of those with you.
Okay, great. Thank you. Sorry to take you back.
Yeah, no worries. So, Richard, we were talking about this the other day, is why is it important? Well, we need to optimize the yield and quality, both from an economic standpoint. Our farmers want to be good business people and be profitable, but it's also because of resource stewardship. And as we just talked about the weather outlook, how much water are we going to have? We may be in a situation where we don't have all the water resources that we want and need. And we also have water quality issues, water quality control board, and groundwater issues. We've been over tapping our groundwater when we don't get the snowpack that we need. So we need to be good stewards of our resources for dozens and dozens of different reasons. And that's why irrigation scheduling, and as Tom will talk later, distribution uniformity, they're both very, very important to optimize both of these topics.
When I look at resource stewardship, and I was just looking at the price of organic grains the other day, and how much more growers are getting for organic grains. And I started to think, will we ever see a day where people are advertising that they're using proper irrigation, drip irrigation, whatever, in the marketing of their products? Oh,
I think so. Even during my brief 40-year career, I've seen that. I've seen that come to life. I mean, 40 years ago, organic was just a pipe dream, and now it's mainstream. And I think in the future, people now are more interested in where their food comes from and how it's grown than ever before, at a time when they're more disconnected with where their food comes from and how it's grown. The urban-rural disconnect is huge. So whether we actually get to a point where we have something similar to, like a LEED certification for buildings, whether we have some sort of a LEED certification for food, I have no idea. But there are lots of efforts in that direction to be able to label food as appropriately grown. And that's the problem. How do you define appropriately grown? And part of that certainly is water, fertilizer, labor, and electricity and fuel and energy.
Yeah, and it's an important place where we really need to share our story with the world, because as Inge said, a lot of people don't know what goes into food production, and that the reality is it does take water to grow food.
Yeah.
But we have to be very good stewards of it.
Yeah, we can do a better job for sure. We know that we can do a better job, and we will. We have to. So there's no doubt. But it is going to take some water to grow food, but probably not as much as we have today. I think we can do a better job.
Yeah, Tom, I think the Almond Board's doing a lot to promote this. Is that right, as far as sustainable growers and
Yes, and you know, Richard, I've worked in a lot of crop sectors prior to being with the almond board, and I have to say the almond growers have been very, very progressive. It's a great group of people to work with, and they're willing to change and do things differently, and they know that this is a place where for the world and for their own sustainability, they really need to be as good at it as they can be.
It's exciting, Richard, if I can pipe in, it's exciting that the almond board and the almond industry here in California is so engaged on, better water management, because they have a big footprint. Almonds have a big footprint in the state. Tom and I worked together on an article that was in the Irrigation Today magazine from the Irrigation Association last year. And if you read that, you'll see that it's 1.5 million acres. It's an incredibly valuable crop. I mean, look at the protein content of almonds. It's an important, valuable crop. We need to keep growing almonds, and we need to keep doing a better job with the resources that it takes to grow it.
Yeah, absolutely.
So beyond the why is this important, Richard and Tom, we all know that there are numerous people involved in this topic. Okay, who's doing the scheduling then? Okay, we know what it is and we know why it's important, but okay, who's doing this? And it can be a variety of people. I just put 4 people up here, but it could be 20. If it's a small farm, it may be just the owner calling the shots every week on when they're going to run the water. If it's a larger operation, it could be the farm manager. If it's a huge operation, like the one I used to work on right out of college, Minahoma Land and Farming, where we had 13,000 acres of permanent crops, I was part of the in-house consultant team. If the farm is huge and they don't have their own team, they're going to have an outhouse consultant team. They may be hiring people to do it. And in some cases, it's the irrigator. Sometimes there's kind of a disconnect between management and field, and they may just be leaving it to the irrigator, and that could be scary or could not be scary, depends on the expertise and the aptitude of the irrigator.
Inge, I'm so glad that you have this slide, because this is where I say a lot of farming operations can be challenged. Communicating amongst this group can be complicated.
Yeah.
It's very important, though, who's actually doing it. I know when I was dealing with technology, sometimes the owner was really into technology, but in reality, the irrigators went ahead to live with it.
Yeah.
And sometimes you're disconnected.
And I could have easily had another slide here.
Yeah, this is very important.
Oh, I'm sorry. With you making that comment, I wish I would have had another slide up here that I have from other presentations that show all of the different areas of expertise that the owner of a farm has to master. They are business people. They are, they have all the mechanical aspects of a farm. They have soil and seed and fertility and insects and marketing and accountants and lawyers and all sorts of different disciplines that the farm manager is juggling and managing as the manager of their enterprise. And, it's silly for us to assume that they're also going to be irrigation experts or, because you really do, it's a scientific discipline, irrigation. And if you don't have the background for it, you can get it wrong, and it could be very costly, both for your farm and for the environment. So I'm hoping that farmers will recognize this more in the future and will, take advantage of the expertise in the communities around them, whether it's from the almond board, whether it's from the manufacturers like Jane, whether it's from the dealerships that build and construct and design the systems for them, or the independent consultants out there who are irrigation scheduling and fertility management. I'm hoping that the farmers in the future will pay more attention to that and budget that into their enterprise to get that expertise, because it's more important than any of the other ones, I think. more than insects or weeds or a number of other ones. I have a friend who's a prominent agronomist in the state. He says that 3/4 of the plant doctor calls that he's asked to come out and troubleshoot what's wrong with the crop are water related. It's not disease, it's not bugs, it's not weeds or even fertility. It's something wrong with the water and the soil relationship. So we need to pay a lot more attention to it and pay the people who can help, with that task.
This is where I like Jane's approach, Richard, of your water management services, that it is a lot of parts, and to support a grower is so important.
Yeah, thanks for mentioning that. And the way I look at it too is things like fertilizer, weeds, vigor. This is all part of the water equation, right? They all feed into that.
Yeah,
absolutely. It's part of the agronomic life cycle of the crop. And, you can say that water is just part of it, but maybe we're prejudiced because we're in the water sector. But I think it's safe to say it's the most important. Nothing's going to grow without water. So, we're a little challenged in that there's not just one person, there's not the PCA on staff, either in-house or out-house, that's calling the shots on crop protection. Irrigation could be done by a number of people, and it's very varied as to what their level of expertise and qualifications are to make this decision properly. So hopefully that's a challenge that we can meet in the future by training and elevating the importance of this topic to the management community. So my next question is, how is it done, right? So we know what it is and why it's important and who does it, but basically, how is it done? And I'm keeping this super, super simple, Richard, because I didn't want to get into a lot of technicalities here. But as we just discussed, it's the first thing is, how much does the crop need? And the terminology in our world is here in the United States at least, is in inches of water per day. We need to find out how much the crop is using in inches per day. Lots of different ways to find that out, but that needs to be known. The second thing that needs to be known is, what is the system's application rate? And that's usually expressed in inches per hour. So if we know what the crop needs in terms of inches per day, and we know what the irrigation system's application rate is in inches per hour, we should be able to come to how many hours in theory a day the system should run to meet the crop's needs. So for example, if the crop needs 1/3 of an inch a day, 0.3 inches per day, which you may have found out from the newspaper, from the morning radio show, or from the California CIMIS, California Irrigation Management Information System, which is a wonderful resource we have in California, or a weather station on your own farm, or a consultant, or a variety of ways to find out what that number is, but that needs to be known. And then if you know what your irrigation system's application rate is, and in this example, I put down 1/10 of an inch an hour, that should be known when you purchase the system. And if you don't know what it is, then an irrigation dealer can come help you figure that out. Or, as Tom is going to show you, the new Almond Board's slide rule calculator can help you figure
Yeah, we
that
have
out.
a tool for that now.
Yeah, we do have a tool for that now. If you know how many emitters you have per tree, if you're on drip, what your spacing is and what the flow rate is, you can calculate your application rate in inches per hour. So however you find that out, that needs to be found out. Yes, Richard.
I think what throws people off is that a lot of times irrigation components are in gallons per minute or gallons per hour.
Yep.
And then somebody says, well, how many inches? So help us out with that.
It needs to be translated. You're absolutely right. The emission devices, the sprinklers are in GPM. Many of the emitters are in gallons per hour. Some of them are also GPM. So gallons per minute, gallons per hour, that's the application rate from this one little device. but there are numerous devices per acre or per tree or per plant, and it needs to be translated into inches per hour. Okay, you're going to make me get technical. So there's 27,154 gallons of water in an acre inch. So at the end of the day, you have to calculate how much water are we putting on per acre per hour and translate that into the inch figure. You could talk about, hey, I put on 27,000 gallons of water per acre today, but nobody would know what you were talking about. We in the agronomic community, we talk about how many inches per day and what our application rate is in inches per hour. Now, in the landscape sector, some people do think in terms of how many gallons per day or, whatever a potted plant needs or a landscape plant. But in agriculture, it's generally, acre inches.
And fortunately, there's lots of conversion charts already made for you, so you can see this.
Yeah. So it is. It's a conversion exercise, and lots of different people can help you do that. And as far as the application rate, you just have to do that once. You just have to know what it is for that field. Of course, we know that depending on what the distribution uniformity is of that system, you have to derate that application rate. And Tom's going to talk about that. But as far as your crop water use, the common nomenclature is ET, evapotranspiration. And, agencies such as University of California or State Department of Water Resources, there's lots of different people that have a ton of information on that. So you should be able to get both of these numbers fairly readily available. And at the end of the day, their schedule is basically taking that 1/3 of an inch a day and dividing it by the 1/10 of an inch an hour to find out how many hours a day you need to irrigate. And, practically speaking, in this example, maybe somebody isn't going to turn the system on for 3 hours a day. Maybe they're going to turn it on for 9 hours every 3 days. And depending on whether the root zone can handle that and lots of other agronomic issues, that's perfectly okay. But that's basically how it's done. We have to find out how much the crop needs and how much we're putting on per hour with our system, and then come up with a theoretical hours per day. So, as I said, there's tons of resources, crop water use, DWR, CIMUS, you can have your own weather station. The Almond Board's Irrigation Continuum, which is a really nice document that helps growers with these questions. Commercial services, there's more of those available every day, which is good. And then the application rate, draw upon the irrigation community, such as the manufacturer or the dealer that sold the system to you. If not, a consultant or a commodity group like the Almond Board should be able to help you. Here's an example of the irrigation improvement continuum that is in a very, very nice manual that the Almond Board produced years ago. I helped, I think, simplify this little schematic on it, but it talks about the irrigation system, water use, monitoring soil and plant, and the management, and then going through kind of a 1.0, 2.0, 3.0 level of expertise. Very, very nice. And then
well described, Inge.
What's that?
Well described.
Yeah. I mean, again, I really have to give credit to the Almond Board for doing this for their commodity group. I just really love it. And again, it's 1.5 million acres, big footprint in the state of California, very important crop. And then the project that Tom and I worked on last year was this irrigation slide rule calculator. And this is the scheduling side of it. And he's going to talk about the DU side of it. So some very nice tools available to help. And, I'll just briefly talk about the irrigation runtime estimator, since we're on that topic right now. The way this calculator or this slide rule works is that you have 3 things that you need to know and maneuver on the actual slide rule. I don't think you can see this. Here.
I think that fades into your background, but I love that you guys called it the slide rule, right? That was the predecessor to the Texas Instruments calculator we all owned right after slide rules.
Yeah, well, so here it is in the flesh. It's very handy. You can have it on your pickup dashboard or whatever, but basically you just need to know what your gallon per hour is of your emitters. And in this case, it's a 0.6 gallon per hour emitter. And then you set A at B, which is what is the average lateral spacing. So this is dual drip line on a 30-foot by 30-foot orchard. So the average lateral spacing is 15 feet. So we've lined up those two things. And then over here is what is your emitter spacing in the field, and that's 3 feet. So the third thing we look at over here is lining that up with your system DU to get your application rate. So it's really, really quite simple. Average lateral spacing 15 feet lined up with 0.6. And then we'll slide it over here with the 3-foot spacing. And voila, we read what the application rate is. And in this case, it's 0.018 inches per hour at a DU of 85%. If you had a DU of 70%, we would derate the application rate and it would then become 0.015 inches per hour. And that would be the figure that you use for irrigation scheduling. So mystery is over. You can just pick up a slide rule from Tom and calculate it if you don't have that number available from your dealer or your manufacturer, and you're good to go. So
yeah, that does make it pretty easy, you guys. Thank you. We've already had somebody ask, where do I get one of these? How can I get one? So
call Tom, Tom.
It's very easy. Just drop an email to fieldoutreach@almondboard.com with your contact information, mailing address, and we'll take care of that, Mr. Gates. I see that's who's asked.
Yeah, it's a really cool tool, and you're really going to like what Tom's going to show you too. So, so just other influences, as I mentioned, irrigation scheduling is not just a slam dunk. Hey, what's my crop water use and what's my application rates 3 hours a day? We have soil issues, we have crop root zone depth. In the vegetable arena, wetting pattern is super, super important. Sometimes that dictates the schedules because we want to blacken the bed, especially at the propagation and setting the transplant time. So other cultural activities, sometimes it's not convenient to irrigate if we're out there doing weed work or insect work or pruning work. And then, of course, the time of the year, whether it's January or the dead of summer in August, and whether the crop is young or whether it's mature, all of those things will influence how much water we want to put on the crop. But luckily, there's a ton of things that can help us, starting with the shovel. And I would advocate that we never get rid of the shovel or the probe, and that we always have that in the back of the pickup to double check all this tech that we might have. So we might have probes, we might have tensiometers. More and more, we're getting automation. We're irrigating from the sky and monitoring from the sky. But at the end of the day, whatever we're calculating in theory, we need to go, the most important thing we can put in the field, as they say, is the farmer's footsteps. Go out there and take a look and kick the dirt and dig a hole and make sure that you're getting the results that you want based on these calculations and or this technology.
Trust and verify.
Lots of
trust and verify.
Absolutely. Yeah. I wouldn't presume that we're going to schedule that way, but we should go double check. So as I said in the beginning, all of this is really important, but it really loses its value if the system is not working properly. You can be the best scheduler in the world and still waste a ton of water and leave a ton of crop money on the table if the system is in disrepair, either because it was engineered wrong or installed wrong, or more importantly, probably because it wasn't maintained properly. And that's what Tom's going to talk about. So take her away, Tom.
All right, let me switch over here.
Okay, I'm going to stop sharing.
Okay, has everybody got my screen up there now?
That
Yeah.
looks great. Yeah.
Great. So uniformity. I mean, really, when we think of uniformity, as Inge says, we want to make sure that when we apply irrigation water, we're getting the same amount of water out of the drippers or sprinklers near the pump as we are at the far end of the orchard. And over time, those things change. And fortunately, we have really good design people in California. Engineering's normally not the problem. It's usually just what happens to things over time, right? So this is an example of a system in Oakdale. You can see all the sprinkler patterns, pretty much uniform, and really that's what we're looking for. So in a perfect world, when we look at a orchard, here's an example looking down at an orchard from a design. All those circles are the same size. And that's what we'd love to have. But over time, things change. And really, we end up in a situation like this, where things have gotten clogged. We got a clogged riser. And here, the second row up from the bottom, you see there's a section of trees there. The circles are smaller and they're getting smaller out to the end. That's a clogged riser or pressure regulator. And it's restricted the flow on that line. It's a maintenance issue, sometimes hard to identify. And then the further you get away from the pump, debris and drip lines start to build up. We're not flushing enough. And all that debris is getting pushed to the ends. And you see this reduction. And it hurts you in flow, and it hurts you in spray pattern. If you're using a micro sprinkler or a sprinkler, your spray pattern, the diameter starts to restrict. And so over time, this can cause real problems. And when we get into some of the financial side, you'll see the economics around this. So here's looking down a tree row. On the left of the screen, the water's coming up from the ground, going down the drip line to the end of the row. Our goal is have that to be nice and even. Soils impact this a little bit, but we're trying to get the depth of water applied to be pretty even. But when we have clogging or pressure challenges, what happens is the trees at the end of the row, well, they start to suffer. They're getting left out of water. And there's a way to overcome that. And the way we do it is we over apply water. So we have to run our irrigation longer than needed so we get adequate water out to the trees. And if you have well percolating soils, that doesn't really impact tree health. You're just wasting water. And if you are injecting nutrients to your system, you're also wasting nutrients. And of any year that we don't want to do that, when we have nutrient products that were $200 a ton last year, they're $800, $900, $1,000 a ton this year, we're talking real money. We're losing money, and we're flushing nutrients through our root zone into groundwater. Neither one of those are a good thing. So we really want to overcome that. So this is why having a very uniform system is so important. And when we look across systems tested, so there's a number of groups that do system testing, we see where we kind of lie as a state. And this is data from Tehama County Resource Conservation District. They do system uniformity testing for us. Other group, we do stuff in Kern County with the Northwest Kern RCD that do testing. And so Tehama County gave me the results of a few hundred tests so we could see where we fall. So
does
yes,
everybody do a distribution uniformity test on their farm or ranch?
No, very small percentage.
Yeah, and why not?
It's hard for the grower to do. You really need to have somebody to come in to do it. And it takes time. And it's why we provide some sponsorship, some funding. We wish we could do more, but to some RCDs to help offset some of their costs. So in the case of Tehama County, they provide that service free, but they can only do so many a year. And surprisingly, some growers don't see the importance of it. They don't understand. And that's why having this opportunity to share the impact. And when we get to the financials, it's kind of shocking, the financial impacts. But this is available. as a service by a number of consultants and groups across the state, and in some cases free. NRCS provides funding to offset the costs. So if you do have to pay for it, there are some incentives to help with that. But it's really important. So in this example, a third of our systems are running in what we call this excellent range. They're likely new systems or people are really on it. The place I see a lot of interest in this is in Kern County. A lot of growers in Kern County do this testing. Some do it every year because their water is very expensive. And they know they have to be really good with their water. So in Kern County, it is adopted much more widely by growers.
Richard, if I can pipe in, Richard, that's an excellent question. And yeah, we truly believe it's low-hanging fruit that more and more farmers need to have these distribution uniformity tests done. We in industry and government agencies and so forth, we need to figure out how to make this more readily available to them because it's a really valuable number to know. And Tom's going to show you why.
Yeah, and there are some groups trying to simplify the testing procedure because for a crew that's really good, it's about a 4-hour job.
Yeah.
I mean, a crew that does it all summer long. So you can imagine to a grower, that's a couple of days, right? It's a lot of work.
Right. But it's a set point, right?
Yes.
Then you know, and you can improve off that number.
Exactly. And we really recommend you do it every 3 years, at least. And I've got to applaud the growers in Kern County that do this annually. Because they're really, it's encouraging that they understand how sensitive this is, right? From the public's perception of agriculture, from their personal sustainability. This is really important because, times are hard in ag right now. Prices are down on crops. Input costs are extremely high. We're in a drought, water costs are very high. So it's really important. So other areas in this, we're doing about 37% of what we call in the good range. Could improve, but in good range. And then you can see, approaching 40% are getting pretty rough. We need to look at it. So the other part about it, regardless if you get a test done, the data tells us we need to do the test. Or the data tells us we do have problems with maintenance, maintaining our systems. So I'm an advocate for make sure you go out and clean your system up every year, even if you're not getting a test, because the tests reflect the most common reason for poor uniformity is system maintenance. That's the most common reason. So if I could bring up the whole industry to do a standard annual maintenance plan, I'd probably bring up the uniformity without testing, right? So, and the biggest thing is clogged emitters, and that's a flushing challenge. So, and the other thing
this statistic here, 27% flow meters, that means 27% of the systems had a flow meter?
Yes, yeah. So that's one thing we ask when these tests are done to kind of give us some statistics on what standard field equipment is. So a third of growers have flow meters. So that tells me a third of the growers actually are measuring how much water they're applying. And 2/3 of the growers don't really know.
Right, that's the reverse was what I was worried about.
They're doing a back of the napkin calculation. And I love this kind of information because it really helps me understand what kind of outreach and education I need to do, right? But I would read this in the reverse. It tells me 2/3 aren't using flow meters, right? Big, good catch, Richard. So back to the maintenance. This is an example that leaks do add up, and this part is part of the maintenance. Leaks do add up, and they measure up to a lot of water. And this is why over the last couple of years, we've really been pushing this topic hard. Just give you an idea here. I had the RCDs measure leaks in the field while they were doing these distribution uniformity tests, right? I said, if you come by a leak, put a catch can under it. So a missing sprinkler, microjet, almost a gallon a minute. So in one irrigation system, that one missing microjet, almost 47,000 gallons from one missing sprinkler.
Yeah, wow.
Yes, there was some benefit there. It recharged the aquifer, but it maybe killed a tree next to it, right? So improper repair. The second photo might be hard to see on the screen, but that's a spray. That's a leak from probably a coyote or bird pecked it at the tubing. They punctured it and the crew repaired it with a goof plug. Well, the goof plug had a flow of 12.5 gallons per hour, which is higher than the drip emitter did. And there is a drip emitter there as well. So they're getting twice the flow there. So that's 12,000 gallons in a season from that repair. Rather than splice in a new piece of tube, they just put a goof plug in and sprayed. Leaks at the filter. These are a big one. This is a flush valve that drips. Doesn't look like it's dripping very much. You know, 2/3 of a gallon a minute, but that's 20,000 gallons in irrigation season from a drip. And literally I was there, took this photograph. It was a drip. We measured it. And then another example of things that need to be cleaned, the risers at the tubing risers, the screens in the risers can get algae or debris in them and clog them. They had a loss of 12 PSI through that screen. So if the system's running at 20 PSI, the dripper needs 10 PSI to activate correctly, but you're losing 12. Now you're down to 10, down to 8 PSI. You're not even getting flow out of your dripper. So, and that's just a flushing challenge or a system maintenance challenge. So really important. And just to quantify this, we took one orchard that we did a test on, 12-acre orchard. They were losing almost 25 gallons per week to leaks that we walked by and captured the flow on. They had more leaks than this. This is just what we captured. And you know, how much water is that? And I always like to illustrate this in visuals so you can see it. Richard knows I like visuals. So if you think of a Kim tote in the field, that's 330 Kim totes of water. So just think 330 Kim totes stacked up over at the pump station. That's how much water they lost that week in irrigation.
I love that visual, Tom. Thank you. That's really good. That really makes an impact. And man, you know, depending on what you're paying for water.
Sorry, I said 330, 73 Kim totes.
Depending on what you're paying for water too. I mean, this can really add up.
And the nutrients that you're injecting also are on top of that. So it's really important.
And we mustn't forget either, it's not just an economic issue. It's this water and fertilizer is going places where it's unwanted.
Yes.
Sometimes it's very dangerous. I mean, it becomes, you know, it can pollute waterways and our groundwater. So it's bad on so many different levels.
Yeah, all the way around it's bad. So this really drove us to, how do we illustrate this? And how do we help provide a tool to a grower to help understand this? And it was great. The Almond Board partnered with Inge. We worked together to go old school, to do one of these old school slide rule calculators. As an irrigation designer, I had a drawer of these. I still have. I probably have a collection of 50 of them. I love them. So we came up with this slide rule calculator, and I'm so thankful that the Almond Board afforded me as a staff person the resources to do this. And we're just rolling this out to growers now. And what's it calculate? We have two sides. So on the front side, it's calculations to really understand the financial side of poor uniformity. What's the impact between a 95% or 85%? What's the big deal? It's only 10%, right? So it really helps us understand that. And then on the back side are just some traditional irrigation calculations, because application rate, like we spoke earlier, hard to understand. I still have growers that they think, well, my application rate is 10.5 gallons an hour because that's what my dripper puts out. They don't understand that we're talking, it's water applied across an acre of ground, right? And I understand why they're confused. We throw all these different units and measure at them, and we try to let them figure that out. So the backside, the calculator helps you calculate what your application rate is, what a run time would be if you're trying to apply a certain amount of water. And it lets you understand things like, what if we want to deficit irrigate? In almonds, we like to deficit irrigate for whole split. So what if you want to deficit irrigate? So here, I'm going to run through a calculation just so you can see it. So I zoomed in a little bit here, and we're getting that number 95%. Of course, everybody's 95%. I got a brand new irrigation system, or we do a good cleaning process, so we're 95%. But the statistics tell me you're not. If I just run the statistics, you're not 95. You're likely more about 85, or you could be lower than 85. So what's that mean? So we changed that number to, we dialed this in with the slide rule, we slid it to 85. So I'm going to look at the what the financial cost and yield is going to be. So we figure in almonds, statewide average about 2,750 pounds an acre for a yield, $2 a pound. It's a little lower than that. We're pushing to get that price up. And hopefully we get through COVID and shipping and all the multiple issues that have driven pricing down. But we hope to get price back up, but we're going to use $2 for easy math. So we got $5,500 an acre in revenue. So let's dial that in. So if we dial that in and we look at what the cost is per acre, it's about $655 an acre in loss income between a 95% and 85% uniformity. That's money I'd like to have. On a lean year, that can make a difference, right?
Yeah, significant, especially when you start, this is per acre, right?
Yeah, per acre. Now we're going to look at, well, what's the cost? I'm just looking at water, but this second on point C there, you can put in a number for what the cost of water or water and fertilizer is, right? Fertilizer, I was scared to run the number at the price of fertilizers this year. When Inge and I designed this calculator, who knew that fertilizer costs could go 4 times what they were last year? I don't even know if our scale will work that far. You'd have to multiply, right? But I'm going to say that we paid $300 an acre foot for water. Okay. So we're losing $36 an acre to over apply water to get enough water to the trees in the end row. That's essentially what we're doing. We're having to over apply water to get all the trees enough water. Okay. So what's that really measure up? So here, we're under $700 an acre, but nobody's irrigating just an acre. Nobody's growing only an acre of, in our case, of almonds. Let's look at 100 acres, $70,000. That's a lot of money.
And Tom, that's just comparing a DU of 95 versus 85.
Yeah, if you were at 70.
Which I think we know for a fact that there's a lot of 60s and 70s. I was just talking to somebody yesterday about DU tests coming in at 60. They were astonished that it was that poor.
And we could have gone on and added in the energy costs because you're going to have to pump longer, right? So you got energy costs. And this year, if we were, if I'd included the fertilizer cost, it would have been daunting, right? Yeah. I only included $300 an acre foot. I didn't include, that could have been $1,100 for water and fertilizer per acre, right? So it's really, really important to look at this. And this is why we did this slide rule. You know, it's not perfect. It's really to illustrate the cost. And some people will go back and forth on what the yield difference is. We figure a percent yield, what do we say, Inge, per percent drop, a percent of yield loss, right?
Yeah,
That's kind of the industry's used that number for a long time.
Yeah, that's kind of been an industry standard for a while, that for every percent loss in DU, you're probably a corresponding crop loss of about 1% as well.
Yeah, and I think I looked at some research in the 0.7 to 1% range. Yeah.
Yeah, I mean, you'd have to do, I'm sure there are instances where university researchers have documented the exact amount for that crop, for that year, for that situation. But to get an overall figure for just to, as a starting point to have a conversation, we use 1% to 1%.
Yeah, yeah.
We got a bunch of questions coming in right now. And the first question is, if I grow something other than almonds, can I still use this slide rule?
Yes, yes. Yeah, the calculations. And you know, we developed this for almond growers, but really as a gift to the industry or growers in general, you know, I wanted it to apply to, it'll apply to any crop pretty much, right? And yeah, I don't think we're missing, I mean, the calculations are universal, so.
Absolutely, yeah. I mean, it asks for your crop water use in inches per day, and that could be for any crop, but we built it for almonds, but it, you know, it's anywhere from 0 to 0.5 inches per day. And then your application rate, you know, it's built to look at drip irrigation.
So they're also asking, something happened with Inge's audio there. They're also asking about how much flow variation among same rated emitters on a system. So Tom, maybe you have that?
So it's a great question. I'm actually giving a talk next week that's going to dig in with examples of that. But when I go out and do DU testing, I would say the flow variance on a well-maintained system, they're fairly even, but it can be anywhere from no flow at all to doubling what the specified flow is. Usually you don't see high flow. You know, I will hand it to manufacturers like Jane. You guys do a good job designing these drippers. So it's usually, it's a clogging issue that's degrading the flow. But if your dripper is designed to deliver half a gallon a minute or so much an hour, it's flowing that. Yeah, yeah. So.
Okay, good, thank you. And then we have another person, Tom, that's asking about deficit irrigation. What is that? Can you explain that?
So in different crops, and I'll speak to almonds, there are times that you may want deficit irrigate. You're purposely under irrigating for a crop response. You're trying to do something to the crop. Now in almonds, as we go in to prepare for whole split, we're trying to promote whole split. So we'll stress the crop a little bit. So we'll under irrigate for a period leading into whole split. And other crops have different reasons for deficit irrigation. Maybe you're trying to drive sugars, you know, so there's different reasons for deficit irrigation.
Yeah, welcome back, Inge. We just lost you for a moment there, but we were just
for some reason, I zoomed out and then back in.
Yeah, happens all the time. That's the wonderful world of Zoom technology these days, right? So, okay, and then somebody's asking again, what was the email or website address for the slide rule again? I think it's in the chat, but maybe you can tell us again, Tom.
Yeah, so it's field outreach, all one word, at almondboard.com. And please include your mailing information so we don't have to email back to you to get it, but we can have one mailed out to you. And I'll show in a couple of slides other resources as well.
Yeah. So, well, listen, guys, we are out of time, but I want to say thank you so much. I really appreciate it. I really learned a lot, right? Sometimes taking irrigation back to the basics is one of the best ways to learn it. And I know oftentimes we skip past those basics And as a result, we lose a bunch of people, right? Because it's still, right? We tried to say this was basic and easy, but it's still very complicated. And so you guys really made some things easier for all of us to irrigate properly. Certainly, I'm going to be looking at the DU more closely of all my systems, and especially when I think about how much money I can save from that. So Tom and Inge, thanks so much for bringing this to all our attention.
Thank
You're
you,
welcome.
Richard, very much.
Thank you for the invitation, and thank you for the Almond Board for the good work they're doing with their growers. And hopefully we can continue this process of becoming better irrigators.
Yeah, definitely. So thank you guys. Thanks everybody for tuning in today. We really appreciate that. Remember, you can find a recording of this on the Janes USA YouTube channel. We'll also send a copy of it out to everybody. And then we also will be listening to this anywhere you listen to your favorite podcast. I love the fact that people are working during the day and listening and educating about water management every day. Nothing makes me happier than that almost. So thanks again, everybody. And we'll see you next week. Have a good weekend.
Bye-bye,
All right.
everyone.
Thank you. Bye-bye.